Alright, you're welcome to Sa Majesty Easy World Science Channel. In this live chat, I will be handling some of the questions that is likely to challenge you when you get into the examination hall, and there is a final revision for you to score very high. Sorry for starting it late, almost 2 hours behind schedule, but these questions are carefully there to teach you many things you need to know. So the questions, most of them are compulsory, and these things will help you score very, very high when you get into the examination hall. Remember to ask your questions. I can see one person there, so you're welcome. Then, okay, about 3 of you, you're welcome. Let's start with the question immediately. I'll be running those questions, about 40 of them. Let's see a display of the questions. Okay. These are the questions. I will answer them and explain them very, very well. Okay, thank you. Thank you. Thank you, Based Academy. Thank you for being with me always. So I'm going through the questions so at least you can see the questions. Then I'll start explaining all of them. These are compulsory, some questions that might challenge you, of course, and definitely it covers the topics that you need to know and some of the weaknesses that students face. Just like this 15, question 15, we are seeing here, we can solve first law very well, but when it comes to second law, students generally battle with it. So the main aim of the video is to help you score very, very high, at least to get 90 and above in chemistry. Most of the questions here are not regular past questions. Some are past questions, some are there to teach you some things you don't know while reading on your own or what your teacher did not reveal to you. So there are 40 questions I'm going to attend to, and then you can also ask your own questions. Any question you ask, I'll see it live on the screen. You guys are welcome. I've displayed these questions on a separate video, so they are meant to teach you some things. That's the reason for this live stream. You guys are welcome, of course. You can give this live stream thumbs up and share this link, the live stream link, to let others join. So having seen the display of the question, we'll start with number 1 and detailed explanation. The other one says, the first one says, which of the following... Okay, when we go through these questions, you gave me your question on metals and their compound, but these are the major reason for this live stream. Okay, we'll go through them and explain some things. I bet you will learn a lot while listening to my explanations on these questions. So number 1, say which of the following is not a property of a reversible reaction in equilibrium? A reversible reaction in equilibrium, the free energy change must be 0. Yes, of course, that is very correct. B, the free energy change must be positive. No, it is not true. Both forward and backward reaction must be at the same rate. Yes. So all the options are very correct of reversible reaction in equilibrium, but except B. To explain further, if we come to a reversible reaction in dynamic equilibrium, two things are involved. For the reaction to be in equilibrium, the change in free energy must be... I hope you can see what I'm writing. So change in free energy determines the spontaneity of a given reaction, whether a reaction can be, and this relation says change in free energy is equal to heat change minus the product of temperature times entropy change. So three things we need to know. When change in free energy is greater than zero, that means it is positive, because all the numbers greater than zero are positive numbers. The reaction will be non-spontaneous. So in this case, you say that such reaction is non-spontaneous. But when the change in free energy is less than zero, that is negative, meaning -3 -1 negative, the reaction automatically will be what? Spontaneous, meaning it will proceed on its own. But when the change in free energy is zero, it shows that the reaction is at what? For reversible reaction, the reaction is at equilibrium. So that's what we'll learn there. So it must, for it to be positive, positivity of the heat change doesn't, the positivity of the Gibbs free energy change does not show whether a reaction is at equilibrium. So it is when it is zero, it shows that it is at equilibrium. But when it's positive, it shows that the reaction is non-spontaneous, requires external supply of energy. We go to the next question. Question number 2 say, what is the IUPAC name of the compound below? This structure, the zigzag structure, look at how we are going to name this. Starting from each end, this place is carbon 1, 2, 3, 4, 5, 6, 7, and 8. Remember, you count the longest continuous carbon chain. So by so doing, we have that this is carbon 1, 2, 3, 4, 5, 6, 7, and 8. Therefore, our root is oct. So oct, as we can see, A and B is no more accepted. We are looking at C and D, oct. Then this double line shows double bond. So the double bond appeared where? Here. 1, 2. So at this point, you have oct2n, meaning it dropped 2 carbon this side, which is 1 and 2. So you take the lower one. I did not say take left or right. You can take any side, provided, if you look at this double bond, it dropped 1, 2 carbon, but on this side, it dropped how many? 1, 2, 3, 4, 5, and 6. You take the lower one. 6 is lower than 2 sides, so this is oct2n. If this is oct2n, this shows that this is carbon number 1, 2, 3, 4, 5, 6, 7, and 8. So this is carbon 1, 2. So at carbon number 2, there is a branch called methyl. At carbon number 3, nothing, no substituent group. 4, no substituent group. At 5, there is still methyl. So it becomes 2,5-dimethyl. So correct answer is option D. So question number 3 say, calculate the osmotic pressure of a solution of calcium chloride, molar mass or molecular mass, prepared by dissolving 11 grams of calcium chloride in 250 ml of water at the temperature of 19 degrees Celsius. What we do here is that the R was given. R means gas constant. So one of the secrets is that if you see R, you use an equation that contains R, and that equation is ideal gas equation. So it is obvious that the equation we'll be using here is ideal gas equation. All right. So the ideal gas equation states that that's the one we are going to use to solve this. PV equals nRT. We are looking for pressure such that pressure will now be equal to nRT divided by volume. Now, time to find these factors needed. What is our N? N means mole, and from the question here, they told us that 11 grams was dissolved in 250. So we will use mass over molar mass. The mass given, the mass dissolved was 11. The molar mass was 111. So this will give us approximately 0.099, which is approximately, you can take it as a 0.1. Okay, so this is our mole. Then can we now find our T, that is temperature? Because this R was in Kelvin, it means that temperature must also be in Kelvin. So, and the temperature is 19 degrees. You convert to Kelvin by adding 273, so that we have 292 Kelvin. Now the next is, what is our volume? Yes, our volume, they told us, is 250 mil. Once you know that milliliter means cm cube, and 1 dm cube is equal to 1000 cm cube. This means that 1000 milliliter is equal to 1 dm cube. So we are going to divide this because of the fact that the gas constant is in dm cube. So all the volumes must be in dm cube. What are we going to do here? We say 250 divided by 1000, which will give us 0.25. All right. So we are good to go to substitute our values. Looking at the subject of the formula we have made already, this implies now that P, which is the osmotic pressure, pressure is pressure, equals now what? 0.099 times R is the gas constant given to us here, 0.082 times what now? Times the T, which is 292, then divide by 0.25. If you do this, you get option A, which is 9.58 ATM. That's the unit. So we'll arrive at 9.57 something, approximately ATM. So that's the way to solve this. Okay. Then we look at the next question, which says the solubility product of copper 2 trioxoiodate 5 is 1.08 times 10 to the power minus 7, assuming that neither ions react appreciably with water to form hydrogen ion and hydroxyl ion. What is the solubility of the salt? When we are giving solubility product, to calculate solubility, we have to know what we call solubility product is KSP. We'll write out the value we need here and solve on. This is what we call solubility product, is written as KSP. KSP is solubility product, which involves summing the ions in question. So in this case, we are going to write the compound, and that compound is copper 2 trioxoiodate 5. Of course, you dissociate it, you get Cu2 plus, because it's copper 2, then plus what? Iodate ion, but because it's 2, we will balance. So you endeavor to balance both charges and also the mass. So if we do balance charges and atoms, so if you watch this, there is one copper, iodine 2, iodine is also 2 here, oxygen in here, 2 times 3 is 6, 2 times 3 is 6, net charge plus 2 times 1 is plus 2, then minus 1 times 2 is minus 2, and 2 minus 2 is 0. So this means that we are going to use the letter S to represent each. That means that this copper now is just S for solubility, 1 mole of it, and this one gives us 2S. Each ion we get, we replace it with S, which means if we have 3 ions, we'll write another S also, right? So with this, with KSP, we now have that solubility product is the answer we get after multiplication. We are going to multiply this only S raised to power the coefficient. Is there any number there? 1. Multiply by this 2S raised to power the coefficient, which is 2. That will give us the solubility product, so that KSP will now be S times 2 squared. Put these 2 on top of these 2. 2 squared is 4, and S squared is still S squared, such that S times 4S squared, our KSP will now be 4S cubed. Therefore, we go and copy the number. The solubility product was 1.08 times 10 raised to power minus 7. So KSP has already been given to us, is already known from the question, right? So our KSP is 1.08 times 10 raised to power minus 7, and we are good to go, equal to 4S cubed. So mathematically, you are going to divide both sides by 4 to make sure that solubility stands alone. So cancel, such that S cubed now is equal to what? 1.08 times 10 raised to power minus 7, all divided by 4, such that S alone will now be cube root of 1.08 times 10 raised to power minus 7. In JAMB, the calculator you find there may not contain cube. That's cube roots. It may not contain cube roots. Are you listening to me? What we are going to do simply is just write this. Press 1.08 times 10 raised to power minus 7. Then do it raised to power 1 over 3. And you should if you press 1 over 3, it will give us what? Let's check the calculator department. Okay. 1 over 3 is giving us 0.333. Okay. Using 3 or 4 places, you go by that way, which means 1 over 3 is 0.333. So the cube root of this number mathematically is the same thing as 1.08 times 10 raised to power minus 7, all raised to power 0.333. What if you are faced with fifth root? Fifth root, like if they say fifth root, remember we don't use fifth root here, but if they tell you to find the fifth root of 2.8 times 10 raised to power minus 11, what will you do? Simply say 2.8 times 10 raised to power minus 11, all raised to power 1 over 5. That is it. So when we do this, see where we are going to get our answer. Whatever you get here will be our answer. And because this is a UTM equation which have appeared several years, the answer should be C. That's what you get. Okay. Now, what if you go to exam and they give you now solubility for you to calculate the solubility product, meaning they will give you this. Maybe if I give you 3.0 times 10 to the power minus 3 mole per dmq, will you be able to get this answer? You just solve back, meaning this is where I started, that KSP, which is solubility product. Remember, our S now is the 3.0 times 10, so you fix S here and raise to power 1 times it by 2 times this, raise all the answers to square, you will still get the same thing. That's the solubility what product. Then endeavor to watch my video on solubility product. I will upload it, and also watch my previous video for past years on solubility. I talked about the solubility product also. So we move on. Remember, solubility product works well for salts that are spirally soluble. It is not other effective for salts that dissolves well. Okay, the next question is number 5. It says the basicity of trioxophosphate 3 acid is. Basicity is the number of replaceable hydrogen ions of an acid. The number of replaceable hydrogen ions of an acid, as we know, and this implies the acidic hydrogen. And the question said what? Remember, look at what the question said. Trioxo, which means we have 3 oxygen. Trioxo phosphate what? 3. So the formula is H3PO3. Don't be deceived. Please, the basicity, if you look at, if I use the already known example HCl, the basicity here is 1 or mono. Remember to ask your questions for those of you online. So I will see all your questions on the screen immediately you send them. If you see H2SO4, it is dibasic. Fine. It's talking about how many hydrogens. We have 1 hydrogen here, we have 2 hydrogen here. That gives us the reason for such answer. If we also have all the carboxylic acids, the only acidic hydrogen we have here is this H. So this one is still monobasic. But don't use that pattern to answer that here is tribasic. The basicity of this particular acid, this particular one, it is not tribasic at all. I mean, this is not tribasic. Reason is because out of these three hydrogens, only 2 are the acidic hydrogen. The other 3 are not acidic hydrogen. Therefore, don't be tempted. The basicity is 2. So the correct answer is C and not D. Then listen very well, please. If it is H3PO4, this is hydrogen tetraoxophosphate 5. The basicity of this is 3, tribasic. Okay, that's what you will learn here. I'm sure your regular book will not explain this for you. So the phosphate 3 is dibasic, but the phosphate 5 is tribasic, but both have 3 hydrogen. If I draw the structure, you find out that only 2 hydrogens here are replaceable. Here, all the 3 are replaceable. We move on. Number 6 says the depolarizer in Lagrange cell is, Lagrange cell are those cells we use to power our remotes at home. That's what we call Lagrange cell. Maybe you can see over here. If you are open here, you can see this battery here is the Lagrange cell. Okay, that's the common battery you know already. That's the Lagrange cell. So the depolarizer inside this battery that I just show you now contains contains black powder, that is manganese what 4 oxide MnO2, and sometimes mixed with also what charcoal or carbon. So both you can mix, because I produce the battery, but not as reduced, in a larger way, because they are electrochemical cells or chemical cells. You can watch my videos where I use the Daniel cell to generate electricity, even the Lagrange cell. So I'm telling you that that black powder inside is manganese oxide, and in the work is to act as a depolarizer to prevent the accumulation of some gases like hydrogen sulfide. Most times in our battery, for full battery, you can see, or your power bank swell, because it needed a depolarizer that will absorb such waste gas. Okay, the answer to number 6 is A. Then number 7 says whose experiment measured the charge of a single electron. The answer is B. R.A. Millikan. That's B. The answer to number 7 is B. The R.A. Millikan, from the oil drop experiment. From the oil drop experiment, he was able to measure the charge present on each electron. So if they ask you who conducted the oil drop experiment, the answer is R.A. Millikan. Now, what are the contributions of other people in the option? As we can see, the man in the option A is J.J. Thomson, John Joseph Thomson. John Joseph Thomson, what is his contribution in the study of atom? He discovered electron. So he contributed in the what? Discovery of the electrons. Remember, I wish you the best of luck in this your JAMB. Of course, invite me in your matriculation. Don't miss that. Sa Majesty Easy World is here for you. So, much love. Ask your questions as you are there. Now, who discovered the electrons? J.J. Thomson in year 1897, if I'm correct. So, it's still J.J. Thomson that did that. Then the J.J. Thomson also propounded the plum pudding model of an atom. The plum pudding model of an atom, which tells us that atom is a positively charged. So plum pudding model of atom was propounded by John Joseph Thomson. He also discovered the electron from cathode ray experiments. So he discovered the electrons from where? From cathode ray experiments. So this is his remarkable contribution in the development of atom. Then Millikan, we have told you what he did. Then Ernest Rutherford, also his contribution in the development of atom is that he's the one that disproved the plum pudding model of an atom and brought the idea of planetary electrons. So Ernest Rutherford, from the experiment of his 2 students, Gige and Marsden, that's alpha scattering experiment, told us that the plum pudding model is faulty, and now made the planetary electron model of an atom, saying that an atom is made up of a positively charged center known as this center is positively charged, and it is called the what? The nucleus. Positively charged center known as the nucleus, and this nucleus have electrons outside it revolving around it. So this is plus plus, which is the nucleus. Then electrons are all going around it like a planet, though not perfect solar system actually. So this one disproved the plum pudding model, that atom is a positive mass with negative charges embedded in it. That is a plum pudding model. So that's the contribution of Ernest Rutherford. He also discovered the nucleus of an atom, and also discovered the proton. Some of your textbook will tell you that protons were discovered by Thomson. No, it's not true. Is Ernest Rutherford that discovered proton. Then Niels Bohr now modified Rutherford's what atomic model and brought us to what we have today, quantization. That is, the angular momentum of the unbeaten electrons are quantized. Not that these EEE are free, rather he told us, fine, Rutherford is correct, but these electrons are moving in what? They are not just freely moving. These electrons move around the nucleus in a fixed energy level known as shells, something like this. So in the fixed energy level. So he introduced this idea and now tell us that we have to be doing what? Add the electrons. Now they are orbiting in a fixed energy level. That's quantization. And this explained why atoms do not collapse. So Niels Bohr explained why atoms do not collapse. Why Rutherford's model couldn't explain that, right? We move to number 8. What happens to a reaction? Who discovered the neutron? I forgot. James Chadwick. So electron by Thomson, proton by Rutherford, neutron by Chadwick in 1932. Okay. Then what happens to the reaction at equilibrium when the concentration of the reactants is increased? Simple. If a reaction is at equilibrium, as I have this thing here, is standing at equilibrium. If there are two ends, this is end A and end B, it is standing well. But if I apply more force here, are you seeing? If I apply more force, are you seeing this side comes up? So if I apply more force, if I increase the concentration of this end, I will favor this end. But if I increase the concentration of this end, I will favor this end. So let's take this as a chemical reaction where we have the reactants and products. Okay, here is our A plus B to give us C plus D, where here is the reactant for forward reaction and here represents the what? Product. From what I demonstrated now, if you apply more concentration here, you favor here. So the equilibrium position shifts to favor more product. So correct answer to this question is option A. The equilibrium shifts to favor the product. Now number 9 says, which of the following is not a property of alkanols? Which of the following is not a property of alkanols? Option A says they contain hydroxy group. Of course, that's what makes them alkanols. Option B says they exhibit hydrogen bonding. Very correct. They all have hydrogen bonding because of the presence of the OH. So whenever a molecule contains oxygen bonded to hydrogen or hydrogen bonded to fluorine or nitrogen, hydrogen bond is established. So A and B go together. Then C says they are completely nonpolar. It is not true. They are not completely nonpolar. So the correct answer to question 9 is C. They are not completely nonpolar. No, they are polar, but their polarity decreases as their atomic mass increases. As their mass increases, like as you add more of alkyl groups to it, what happens to them? Their polarity decreases, which means that if we have something like butanol and ethanol, it implies that ethanol is more polar than butanol because et and but. So that's it. This is also showing how they are soluble in water. Ethanol is more miscible, no, but the higher members exhibit some type of non-polarity. Now, this says they can undergo oxidation to form alkanals. Of course, partial oxidation of primary alkanals yields alkanals. Number 10 says, which law of thermodynamics states that energy cannot be created or destroyed, only transformed? That's first law, and that's the only law you know. It means that we can't destroy energy for ordinary chemical reaction. We can't destroy. That's the reason why we balance chemical equation. As heats are not created, they can be transformed or they are gotten from another energy source. You cannot just say you created heat. The heat we are feeling here on earth comes from the sun fixing it. Then for you to have, if you burn your wood, you have spoiled that wood. The energy, the chemical energy there, you have converted it to heat. So energy can neither be created, which means heat can neither be created nor destroyed, but heat here is representing energy. So the correct answer to number 10 is B, first law. All right. Remember, second law is telling us that there is no 100% conversion. All right. Then number 11 says, which separation technique is most suitable for separating a mixture of ink components? Ink. Look at the secret. Simple. Anything color, you answer chromatography. If they say ink, chlorophyll, pigments, all these things, anything color, you answer chromatography, because that word chrome is color. So just chromatography is indirectly telling us graph of many colors, like producing a graph that have different colors. Chromatography. Even if you don't know, just know that when color comes in, answer chromatography. So the correct answer here, since they said ink, maybe the tea that was discovered, they checked the tea whether it is containing an impurity or not containing an impurity, and the impurities are color substances. What method can you use to confirm it? Simply answer chromatography. All right. Number 12 says alkanals can be distinguished from alkanones using which reagent? Alkanals can be distinguished from alkanones using which reagent? Simple. There are three possible reagents that can be used to distinguish alkanals from alkanones. That is, alkanals is R H double bond O, while alkanones is R double bond O R. So you see that there is extra hydrogen here. So alkanals are perfect reducing agents, while alkanones are not reducing agents. So you use mild oxidizing agents, such as you can use Tollin's reagent, which is not in the option. So you can also use Fehling solution, which is in the option. So Fehling solution. You can also use Benedict solution. So the correct answer to question 12 is Fehling's solution. Fehling's solution A and B, they all collectively do that job, right? We move to the next question. Number 13 says, which type of chemical bond involves the complete transfer of electrons? That's a kind of bonus question, of course. Transfer, complete transfer of electron. That is ionic bonding, otherwise known as electrovalent combination. Metallic atoms transfers their valence electrons to the non-metallic atom so that both atoms achieve either octet or duplet configuration. Number 14 says, which of the following represents the general formula of alkanones? General formula of alkanones. Like now you have seen me write this. I called this one here. Let me show. It's not that there is a bond. No. Alkanones. So over here represents the alkanones. So they are asking us the general formula. The general formula is, yeah, you have seen me, I wrote R and R. So it's possibly to avoid, and we are not seeing R here, they are now writing it in form of CnH2n plus whatever. So what do you do here? Simple. Note today that when you sum two alkyl groups, you will get an alkane. Am I talking to somebody? When you sum two alkyl groups, sum it, whether they are the same alkyl group or different, you automatically give you what? An alkane. For example, do you know that this is an alkyl called methyl? So if you say methyl plus another methyl, remember this reaction, there is no reaction like this. How many carbons? 1 and 2. So we have C2, 3 plus 3, we have H6. Is this not? So when you do it this way, automatically it gives you what? Okay, we are back. So I was answering the question number 14, the general molecular formula of uh, the general molecular formula of arcanone. So if you sum it up, you find out that the correct answer to that question number 14 should be CnH2nO. Yes, because if you have two R summed up, it automatically gives us what? Takes us to that direction of alkane. Remember, the correct answer here is B. All right.